Hi guys, welcome to today's video. In today's video, we are going to solve a medium lead code problem, maximum number of operations to move all the ones to the end. Okay, so this is a problem that came in the lead code challenge, right? It's 3228. It's one of the most recent lead code challenge problems, right? And it's actually not a very difficult problem. Like if I can just show you once, right? I'll take some examples to make it easier for you guys to understand, and so that you can recognize the patterns in the problem, and therefore it will be much easier for you guys to solve this kind of problems when you encounter them in an interview or during challenges, right? So let's get started. Okay, so see, the problem is maximum number of operations to move all the ones to the end. Okay, you need to read it very fast. You are given a binary string s. Now what did I tell you about a binary string? It's 0 0 1 1 0 0, like that, right? And you can perform the following operation on the string any number of times. Choose an index I from the string where I plus 1 less than s dot length. So what does it mean? I can choose any index I from the string, right? I can choose 0 0 1 1, but additional constant si equals to 1, si plus 1 equals to 0. So now I cannot choose any one. Okay, the I has to be 1 and the next digit has to be 0. So here, if for this string only this 1 is going to be a valid candidate, rest are not going to be a valid candidate, right? So if I have a 1 here, if I have a 0 here, then this will be a valid candidate. If I have a 1 1 here, these two will not be valid candidates. So you can understand, right? This one is going to be a valid candidate. Okay, so we have done the first step, which is reading the problem. Now the question is, move the character si to the right until it reaches the end of the string or another 1. For example, if s is 0 1 1 0 0 1, which is I equal to 1, and the result is going to be 0 0 0 1 1 0. Okay, so what can I do? This is the 1. I can slide it to the right until it reaches another 1, right? So it can take the zeros position, or it can reach the end. So if these two are ones, right, they are not valid. Why? Because if I slide it, it's going to go nowhere, right? And I plus 1 is not 0. So whatever the zeros are there, we have to minimize the 0, right? Now return the maximum number of operations like this that you can perform, right? So now I want you to think, if you've done some string operations before, you would what is the answer, right? This is an input. You're passing in different kinds of input, right? What kind of answer can you get, right? Like if I pass in a string, right, and knowing that answer is kind of the first step to solving the problem. Like you have solved 80% of the problem if you like random string, right? 110 random binary string. Okay, this is a binary string that I'm giving. What do you think the solution is going to be, right? It's pretty obvious. The solution is 1, where all the ones are going to be shifted on the right hand side, right? Regardless of anything, all the ones will be shifted on the right hand side. Why will this be the solution? Because if this is not the solution, right, if this one is not shifted on the right hand side, if it is somewhere, then obviously there's one more operation that I can do where I'm just shifting the 1 to the right hand side, right? Makes sense? Complete should make easy sense, right? So this is always going to be the solution to the problem, right, where all the ones are shifted to the right hand side. Let me write that down. Okay, the result string after operations, but there is one where all ones are shifted to right hand side, right hand side. Okay, easy so far. I hope you guys understand, right? This is the result. Now when I'm getting this and I have to go to this, right? So try to understand that every one that is not the rightmost one. Okay, so every one needs to take a journey where it's going to the right hand side. So this one, right, which one is this one? Okay, which one is this one? Like if I mark this one as red, okay, which one do you think this red is out of all these ones when it's gone, right? Obviously this one, obviously this one. If you weren't able to answer that, I want you to read this question properly, because you have not read it properly. I can slide a 1 until it reaches another 1. I cannot breach this one to go beyond that, right? So if this one is blue, okay, if I'm marking it as blue, then obviously this one, right, this one is going to be blue, right? So now when you look at this problem, right, when each one has taken this journey, I want you to think, right, what how do you get the minimum number of operations? Right, this one is traveling until it strikes this one, right? This one is traveling until it strikes this one. Let me get this pen. Okay, this one is traveling until it strikes this one, then it can travel again, right? So imagine this, right? You are a person, you are stuck. There is another person ahead of you in line, right? There are multiple people ahead of you in line, right? Now you can move forward, when this person, so you can move forward, right, until you are struck by this person, right? And if there are no person in front of you, right, then you can just move to the end of the line, right? So in which step do you think, so whenever you are moving forward and getting stuck, right, you are, let's say you are on a toy cart, right? You're pressing the accelerator here, you're pressing the brake here. So whenever you press an accelerator and a brake, it's one step. So how many steps do you have to take, right? If there's no person ahead of you, you're going to take one step only, right? One step only, sorry. Okay, because you are just going to move. If there is one person ahead of you, you're first going to take one step, and then you're going to nudge this guy, please move sir, and then he moves, and then you take one more step to reach the end of the line. So there's two steps. So the more number of obstacles that you have in your path, the more the more number of operations is there, and the more difficult it is for you to move, right? So if you look at this problem, just think deep, 5 minutes, okay? Take a pause in this video, think of it. You will realize that the way that I want this motion to happen, so that I have the maximum number of operations, is that I first move the leftmost one to the rightmost it can go, right? And then I do the same with the next one, and then I do the same with the next one, and then I do the same with the next one until I reach the rightmost one where it goes to 0. Okay, so now you look here. What did I just do? I first move this one to here, right? Okay, miss the red color, right? So I first move the one here, right? Then I tried to move this one, I cannot move this one. Then I got this one, so I moved it here, right? Then I tried to move this one, I got it here, right? And I cannot move this one again. Now I again repeat this step, right? I tried to move this one, I couldn't move it. I tried to move this one, I couldn't move it. I can move it because there's a 0. Okay, then I tried to move this one, I can move it. So try to understand what path is this one tracing, right? If you are a person that is stuck in an elevator, in a emergency, so each one is stopping whenever he has to stop. Okay, so this is you, this is the person you are, and there are 3 obstacles in front of you, right? Now think of it, right? There are 3 obstacles. So first this guy, right? First this guy cleared the line. This guy moves to his position, you are moving to his position. Now he is clearing the line, then you are moving. So the number of steps that you are taking, the number of operations that you are taking is going to be, you are basically going to go to each one of these guys' positions, right? If this is a blue one, then you are going to be in his position when this one is moving, right? Until each one reaches its end. So if you think of the what kind of algorithm are you trying to form from it, right? If it's bloody, it's supposed to be, right? But I will try to figure out an algorithm from here, right? So I'll write a pseudocode here, right? Basically assume this, if this is a rightmost one, right? If it is rightmost one with no 0 on left, right? If it is rightmost one with no 0 on left, then what happens? If it is rightmost one with no 0 on left, then so we are going to break the operations by the number of ones, right? Then operation for this one is 0, right? Think of it, this one, what will be the operation for this one? This one, it's on the rightmost, it's 0, right? Then if it is the leftmost, if now I'm going from right to left, right? I'm going from right to left. I'm not going from left to right, but I'm going from right to left. Okay, right to left I'm going, right? If it is the rightmost one with no 0 on left, then operation is 0. Now I want you to think, if there is a 0, right? If this is an ideal one, which is being asked, right? If there is a 1 where the right side there is a 0 present, right? For example, this one, right? Just think of it, how many operations does it has to go, right, to reach the right hand side. So the way I can think of it is that there is 1 0 to the right, right? So in one operation it's reaching to the right, right? So if there is a 1 0, operation is 1, right? For the first, right? Now if this one is there, if this one is there, then how many operations does it have to take to reach the rightmost? Think of it, first this one goes down to its place, right, in one operation. Now this one is first going to go to its place, right, and then it's going to go to his it's going to go to the end, right? When this one reaches its place, then it reaches its place. So for this one also same thing, first it's going to go to the place of the preceding one when it's going, and then it's going to go to the preceding one. If think of it, if the preceding one before it has 0 operations, right? So if this one is moving 0 times, then how many times will this one move? There is a 0 in mid, so it's going to move 1 time, right? If this one is moving 0 times, then this one will also move 0 times, because these two are kind of stuck together, right? If this does not move, then this does not move. If this moves once, then this will move to touch that one, right? Very simple thing, right? So for everyone, if there is a 0 in between, right, then it will move. For everyone, if there is a 0 in between, then it will move 1 plus number of steps the previous one has moved. Very simple thing, just think of it. If there is a 0 in between, it will move 1 plus number of steps the previous one has moved. If there is no 0 in between, then obviously it will move the number of steps the previous one has moved, right? If that one cannot move, how will this one move? These two are kind of binded together. If this moves, then only this can go to its place, or when this moves, there is a 0 that is created in between. It's like a spring, how a spring works, right? So this is the very simple algorithm if you look at it, right? So I'm going to try to code it up. Okay, I have written a code for it, but I'm going to rewrite the code so that it's very easier for you guys to understand. And I'm also going to explain as I am writing the code. Where is that? Okay, so I'm going to reset this. Let's see. So I'm going to find the maximum operations where string s is there, right? So what I'm going to do, I equals to l minus 1, I greater than equals to 0, I minus minus. Okay, if just see what I've written, I'm just trying to code up this pseudocode, right? int l equals to s dot length. Okay, now one thing, if what is it, if s dot caret I 0, right? If it's a 0, then what happens? So I will have a variable which is 0, right, equals let's just say put it as 0. Initially I have 0 number of zeros. Okay, 91 equals to 0. We have 0 number of ones, right? If caret I equals to 0, then I'm gonna do a 0 plus plus, right? Now let's say else, if it's a 1, then what do I do, right? Then I have to count that how many steps am I shifting this one, right? How many steps, like if it's this one at the rightmost position, then how many steps am I shifting this one, right? So if so you can think of some kind of approach into CNT equals to 0. So CNT is the count of the one that has been shifted before. Okay, now else it is a 1, right? Now I have to find out that if 0 not equals to 0, right? Else, so there can be two cases. The one is a terminal one, right? Just think of it, right? You're encountering a one like this. Where is the number? This is the number, right? Just think of it as I'm coding this, right? You're encountering this one, right? There's no 0 to the left of the number, right? So how many steps will this one go? Okay, there is no 0 to it, so this one will not go any steps, right? So CNT is still going to say 0, and I'm going to count the sum, which is the number of steps that it's going, right? So sum equals sum plus equals, if it's a 1, right? And CNT, because in between there is no 0, right? If there was a 0, right, like this one is basically going to go how many steps this one will go, right? And if this one, then it's just not going to go there, right? Else what is it going to be? Sum plus equals, let me think of it, right? Sum plus equals CNT, or it's going to be sum if there is a 0 in between. Think of it, if there is a 0 in between, or if there is a sum plus equals to CNT plus plus, sorry, not plus plus, but CNT plus plus CNT. Why? Because I incremented the counter. Now this one will go one more step than that one, because it's first going to catch up to that one, and then what it's going to, as that one is moving, this one is going to move along with it, right? So that way I'm going to go from right to left, and I'm going to solve this problem, right? So once this is done, how is it going to go? Return CNT. Okay, CNT is the total, no, not CNT, but return sum. CNT is the how many steps that one is going, right? So it counts that. I don't need the one I basically created. So that's how you build the intuition and you try to solve the problem. But I want to see if I've solved it right again, right? Okay, I gave a wrong answer. It gave me a 6 when I should have given a 0, but this one is correct. Now let me think of it. Why did it give me a 6 when it should have given me a 0, right? So if s dot caret I equals to 0, it's not 0. Okay, else if 0 is not equals to 0, right? Initially the 0 is 0. Else, okay, this is a mistake that I've made, right? If 0 not equals to 0, sum plus equals to CNT. Okay, sum plus equals to CNT plus 1. Okay, integer, think of it, right? So there's zeros and then there's 1. So what I'm going to do is integer 1. Okay, I will be needing the 1 after all, because I need to see that if it's 0 or 1, right? So I'm thinking of it that if this is a 1 1 1, right? So this should be next to it. If 0 is not equals to 0, then sum plus equals to CNT. So in between, okay, this is the opposite that I've written, right? If 0 is 0, then sum equals to CNT. This is a silly mistake that I did. If 0 is 0, right, in between there is no 0, then sum plus equals to count. So the 1 is going to be the same as the 1 after it. Else I'm going to add 1, because I need to bridge that. My 1 needs to travel to the 1 nearest to it, right? And repeat the algorithm. Look at it now. It's still giving me the wrong answer. So it's 1 0 1. Okay, this one goes here, right? It's 6 and this is 4. So what I can think of is s dot caret I equals to 0, then 0 plus plus. Okay, so it increases the 0. Okay, if 0 is 0, right, whenever I'm doing this, if 0 is not equals to 0, okay, so I need to make 0 back to 0, right? Why do I need to do this? Just think of it. Why do I need to do this? Because I am no longer calculating the 0 in between these two. I'm now calculating the 0 in between these, right? So I need to refresh, I need to make the 0 back to 0 whenever this is happening, and this time it should work. And yeah, see, this works. Okay, so again, it's mostly based on intuition, right? If you have solved 10 such problems before, you will be able to solve this, or else, you might struggle with it, not understanding, how to find this pattern. So I am going to end this video, and I'll upload more videos. So I would highly recommend that you subscribe, and I think eventually you will start to understand this much better. Thank you.